Okay, so I am back, and after troubleshooting a little more, I got to know that due to our overflow last time, we had some errors in the script, and that crashed some components of my system. It was not the firewall, but some components of the system got crashed. That's fine. I just restarted, and it is now working fine. So just restart your system if you face some issues. And when you do this, it says done. So you go here and you see 42424242, right, which is our B character. So if I just show you nano here, so this is our exploit, but right here this is what we are sending. So if you just see, we were sending this, right? Now instead of this, we again want to send the jump instruction, right? So we want to send the jump instruction. Jump instruction in our case was x8 f3, if you remember. This was right here. Actually, I forgot. Let's go ahead and search for that again. Yep. So we gotta go it load it again. We say play right here, and I'm gonna say play again until it works. It is not working. Okay, let me reload it. I'm gonna see a play here. Yeah, it's playing. Let's go ahead and search for the jump instruction again. Or basically, I see it is right here. Jump. Uh, so this is the value. Let's add it right there. So it is 121731, and now let's add x here. So this is what we are going to send as the jump instruction. With that, we are going to send the buff, right? So that makes it. And now the problem is we developed the exploit, um, but we forgot probably that. Let me first of all delete. Okay, I think I press Control C as interrupt. Let's do that again. Um, is being edited by this. Continue. Yes, continue. Okay, so we don't need this buffer here. All right, we are going to create the buffer again, and I remember we did two mistakes. First mistake was that we used the Shikata Ganai and the Windows operating system. By the way, we are developing this exploit for Linux operating system because the brainpan.exe, that is an exe, but the machine is a Linux, right? So we are developing it for a Linux, not a Windows machine, so we cannot use Windows. Second error was that we use the Shikata Ganai, and that's gonna cause a lot of issues with the buffer overflow. I mean, it works, but when you are switching from Windows, because our lab is Windows, but then we are exploiting it on Linux, so it's little, it's little wrong thing to do. Let me just do it quickly. I'm just gonna say right here, I will say Control K to cut it. Oh, I think it doesn't work. And that's all. And here again the jump instruction instead of this. The jump instruction is F3 1 2 17 3 1. This is the jump instruction. Now here we want to put the buff. And with the buffer, you can also do one thing. You can put the null byte. Sorry, you can put the knobs. So knobs will do some padding for you, right? So this is a like it is not compulsory. You don't need to put it, but this is a good practice to do. So I'm gonna show you. Like you can put x90 bytes, okay, and how many it depends. You can put 16 if you want, or you want 20 or 30 40. Let me just put 20 right here. So this is completely optional. This is just to make some padding with the buffer so that our buffer has some good space if something goes wrong. This is just a good practice, completely optional. If you want, you can avoid it, right? Let's bring the buffer now, the overflow code. I'm just gonna clear the screen, and this is the thing we used. Now I am going to avoid the Shikata Ganai now. So I don't want to use the Shikata Ganai. We are going to switch to Linux for the real thing right here. Also, let's use Meterpreter shell instead of shell. Because Meterpreter is more powerful than the simple shell. It's your choice. I'm just changing some things here because I think Meterpreter is much better when working with Linux. The only fact I am doing all of this is that we forgot to uh, realize the fact that this is going to work on a Linux machine, not on a Windows machine ultimately. So we are developing it, but we want it for a Linux machine. Now, as it is a reverse shell, we also need the local host and local port. Sorry, the listening one. So lhost equals 192.168 dot, and now I'm not sure about the IP. 252.137. And local listening port, local port equals anything here, 6666, or you know. You can put it some good numbers like 8080. That is much more better. But I am sure my Windows and my Linux, both of them have 8080 already running with some other thing. Let's keep it for just for the simplicity and just a proof of concept. So let's try this. Let's see if we get some error or if we get the code. Okay, it says architecture 86 was selected from the payload. Great. 10 compilers. This is not correct. Yeah, so this is not at all correct. We don't expect this thing. And is this correct? Windows Meterpreter reverse TCP. This equals this, this equals this. Let's, let's try this again with shell if that works. But I will keep it reverse TCP. And I think there should be an underscore. Maybe the payload is not Meterpreter. 1 second. You can go to Metasploit and search for the correct payload name. And I'm gonna cancel this because this is a staged payload, not a non-staged. So this is a mistake here. This needs to be like this. I'm just waiting if it works this time. So it is again and again giving a very bad code now, you know. What's the problem? So we have Windows, we have reverse shell um, right here. Yeah, so we have Windows reverse shell lhost equals this, lport equals this, dash b right here, dash f python. Let me just clear the screen and write it again. So let me just go to Metasploit and check what the payload is, and I'll be back in a minute. So I have written the command again. And it is working fine this time. And I mean, adding the characters like this works, but adding the characters like this, like the colons, I'm not sure. These are not working maybe. So let's see if we get the buffer code. Now we got the buffer code. That's great. Maybe we were adding some space or all last time. So now we got the buffer code, and this is what we want to copy and what we want to paste here. And we have the buffer. Everything is set to go. Yep. Okay. Let's say Control X and Y, enter. That's all. I'm going to do one thing. I'm gonna start uh, netcat, and I'm gonna start it to listen verbose port on 4444. Okay, so now netcat is listening, and in this terminal, let me just clear this. So in this terminal, let me move to, let me move to home, school, desktop, lab 3, and let's fire up the 2.py this time. Okay, there is some error. It says right here. Okay, we forgot. What is this 20? This needs to be multiply sign here. So we have the shell code. We have set everything. It's just about a multiply sign. We forgot. Okay. Control X, Y, enter. Executing that. It crashes. And we got the reverse shell. See users proficient cool desktop. Can you see that? This is how we do a exploitation, right? Now this is not yet complete. So yeah, I mean that's not all complete. I'm just gonna say exit. Okay, I just exited that. We created the shell code, that will work on a Windows machine. But we need to create a shell code that will work on a Linux machine. Probably we need to use here Linux slash x86 slash this, oh sorry, this, everything will be fine. Most probably that's the correct payload. Let's try that. Otherwise I'll go in Metasploit and search for the Linux payload, what exactly we have there. If it works, if it gives us, okay, it works, and this time it is 470 bytes. That's pretty cool. Let's go ahead and edit the file nano2.py, and I'm gonna delete the buffer now, this one. So let me just delete it. Everything got deleted. Let's copy this up. So just make sure you are on the right platform. It says platform Linux architecture 86. That's really fine. Let's copy this. Let's paste it here. So we have everything set up, and now this is how we do a custom exploit development. So this is the exploit that will, you know, allow us to hack into the Linux box, right? So if I just go here, become root, use netdiscover, because I forgot what the IP address of that machine was, the brain pan. It's gonna take some time, but we have to wait for it. So I believe I should just skip the video. Okay, it took some, you know, some really long time. I got the IP address 135, so this is what I was curious about. I was just gonna say Control C. Now I am, you know, because I know that. Okay, sorry for this. I by mistake pressed this. Yeah. So because I know there is a web server running on this this machine on port 10,000. Just to verify this is the correct machine, I'm just going to say 10,000. Okay. Yes, this is the correct machine. That's all what I need. So I'm just gonna say Control C. I'll say clear. Okay. Now that we have this done, in the exploit, we just want to say IP address is not this. Instead, use the IP address as this. And that's all. So we have the buffer exploit code. We calculated A is 524 to crash this application. This was the jump address, jump ESP address in the Little Indian format because it's a x86 program. This is just for the no operations, just for the padding of the buffer, and this is the buffer. This is how we develop the exploit. So custom exploit with buffer overflow. Control X, Y, enter. And now time to fire up our script right here. And what the, okay, by mistake we forgot to listen. So we forgot to add the netcat listener, and if we do that now, LVP 4444, because if we are doing that now, that's not correct. We should have done that earlier, and now that's fine. So we exploit this again using the same exploit, and now we have the connection. So if I just do something dir, you see there are two files, this thing and this thing. If I even do and I don't think who am I will work. This is not okay, it works. This is Puck, but the problem is this is not a proper shell. So this is not a proper shell, and in these cases we can use some shell commands. So I'm gonna show you one of them, and because we are like we can try to get this shell using Python. We will say Python dash C, and this is just, we are importing right here. So import a file, import a pty, and we are going to import the shell basically. So here, so this is basically the full command. Now you might say, hey, do I need to learn this? Well, you can go on Google and you can search reverse shell cheat sheet, and you will find all shells here. When you run this, now this is a proper shell. This is puck at the rate brain pain, and now you have a proper reverse shell. Variable not set. So, wow, variable is not set. And if you remember, when there is no environment variable, you always have that privilege escalation thing which I show you in the lab 1. So you see ls, there is something like check server.sh, right? When we run this check server.sh, so I am going to give you this homework. Okay, this is the same thing. I'm going to give you this as a homework, that check server.sh, it is probably being run as a root script. And if you remember no, if you remember the privilege escalation in lab 1 which we learned, which was using the file inclusion, the path inclusion, like here environment path is not set, you can set a path to this, you can create a symlink and get a root shell. So this is your homework. It's very simple. We have already done this in lab 1, and let's do that. And with that, this is how you do custom exploit development. This is how you do buffer overflow. I know it was very hard, and it was very hard for a lot of beginners, but you can work with scripts, and it's gonna make your life more easier. And I'll take the leave now. Thank you so much.